Thought I'd make a short video just to show you the inside of a door mechanism from an aircraft. This particular one's from an Embraer 170. It's one of the cargo doors. The mechanism is pretty much the same for most of the doors, or the locking mechanism anyway, a little bit like a safe mechanism. I'll just quickly show you how it works. So the panel there you've got in white, this one here has been removed from here, and it's just really a dust panel to stop all dust and dirt from getting into the internal mechanism. So all you have here is you have your main handle, you've got a quick catch safety lock which you have to push in, then you have to lift the handle and that releases an internal lock mechanism which is underneath. I don't know if you can see that, that also holds that in place. Once that's released, you then literally turn the handle and it's that easy. It has a cog mechanism here which pulls on all of the 4 struts, and these struts are like safe doors, so what happens is once you've closed the actual door, the rubber seal will seal it. However, this will also go into the fuselage of the aircraft just for extra locking systems. In the past they didn't used to have that, they used to have a single catch, and unfortunately there's been a couple of aircraft accidents where the cargo door has been detached and has caused a decompression. So nowadays they have the full locking system as well as the air, as well as an internal suction system that sucks the doors in and pressurizes the cabin, including the cargo cabin. As I say, this is just a cargo door. It's relatively simple, it doesn't really weigh a lot, but it is very, very effective. And it's more about the strut itself. You know, the strength is in the construction of this as well as here, and it's all aluminium, and it's aircraft aluminium, so it's mixed in with another metal. I can never remember the name of it, scandium or something I believe it's called, and it's only 1% scandium, the rest is aluminium, but it's enough to make it a very, very strong structure. You have some more structured type of aluminium here, much thicker, but this is really just about causing enough structure to close the door. But the main thing was about the mechanism as to how that works. It's an internal closing door rather than an external closing door, so the operator would pull this handle and then drop that, press that in, it's locked, and there you have it, that's your door. Very, very simple. Normally this would be over there. I took it off purely to show the mechanism, and this is itself is just made from glass fibre, or fiberglass as some people used to like to call it, which is then coated in aircraft paint, which is a mixture of chromium as well as a standard paint. The green is mainly the chromium paint, and then they have an external paint over the top which is a protection surface. So the reason they use chromium, so this is the outside of the aircraft, this would normally be part of the wing or part of, well, not in this case, part of the main fuselage itself. The reason they used the chromium in it was originally back in, I believe it was the 1940s, when they was trying out jet aircraft. They found that raindrops at a certain speed was called dents to the aluminium. So they changed it, so they put this chromium powder within the actual paint itself, which is very, very strong, and it made it so that the paint was resistant to hailstones, for instance, or raindrops. I know it seems very silly, but when you're taking an aircraft from say 200 to 300 miles an hour up to 1200 miles an hour, unfortunately a raindrop or a snowflake can actually cause damage to your aircraft. So that's why they've done that. But there you go, that small video about a door mechanism. Quite an interesting little bit of kit, really. I think I'll probably clean this up and perhaps put a perspex top over it so it can be seen, and maybe make it into a coffee table, who knows. Anyway, there you go.